Hello. So we are studying studying multivariable case probability with multivariables. And I told you in the previous video that there are three notations you need to know. There are only three notations you need to know to express any kind of event. One is and, or, not. And we studied not case in the previous video. That is complement from the set theory. Today we are going to study and or. So in here, like in this slide, we are going to study or. So we can think of like our basis events are female and healthy insurance, F and H. And then based on them, we can think of a new event defined as female or having a healthy insurance. What is the probability that a person is female or the person is covered? So you can put it as at least one of them happens. So that's the meaning of or, right? At least one of them happen. Both can happen, but it doesn't. They don't need to be like one happens or the other happens or both. So from the set theory, we call them union of two sets. So there are two events, and we bundle them, consider all of them, everything included in at least one of them, and we denote F U H. So this notation is from union U, but usually we call this F cup H, but you may think it as union of F or H or F or H, well, same thing. And this event is expressed, this event includes these guys. It's a union. So everyone who is female is included in that event, and everyone who has a healthy insurance is also included in that event. So these three outcomes are included. These three types of people are included in that union. So as you can see clearly, those people, the colored types, satisfy at least one of the two conditions, female or healthy insurance. And this type, excluded type, fails to satisfy both of them, does not satisfy any of them, right? So they are excluded. As a result, the probability of this union can be calculated from those three outcomes, and that's what you can calculate. The answer is, it's pretty simple algebra. The answer is 80%, right? So if you add these three probabilities, then you get 80%. So that's this calculation is based on the definition that a probability of an event is the sum of the probabilities of outcomes included in that event, right? Now the last operation we learn is and. And so you can think about the event that a person is female and having healthy insurance at the same time. So this means and means both of the events occur at the same time together. So two conditions must be satisfied at the same time. From the set theory, we call this intersection. So we collect, if there are two sets, we collect the elements that are included in both of the sets and denote it as F cap H. So reverse the union sign. This is intersection of two events. And in our probability distribution table, in our example, female and healthy insurance should be satisfied at the same time, and there is only one type. one outcome that satisfy both. The other guys, the other types, fails to hold at least one of them. So for example, they are not included because they do not have health insurance. And this type is not included because they are not female. And this type does not satisfy any of the conditions, right? So in that way, this is, so as a result, and results in a single outcome. This event has a single outcome, so probability should be pretty easy to calculate, right? Because there is only one outcome included in this event, so probability is straightforward. And what you can tell here is, again, this is event. Like it looks like a complicated event, but actually it is a single outcome. So when you have multiple variables, the events and the outcome are quite different, can be quite different. So it is important as the data structure becomes more complicated, it's more important to understand what we are talking about, or like what is outcome and what is an event, right? So we learned 3 operations, and that's all you need to describe, to express any kind of event using the basis event. So now then, and then you can define a new event using more more than one operations. Like for example, what is the probability of F intersection of H complement? F intersection with H complement. So to answer this question, first try to explain, casually speak, what this event means, and then identify the outcomes that are included in this event, and then calculate the probability. Pause the video and do the work. Okay, let me give you the answer. I'm going to denote each of the event first. So F, first we start from F. F is this one, right? Female. And H is, H includes these outcomes, those who have health insurance. But we need H complement, those who do not have health insurance. So we have to invert, switch switch to the other side. So this is H complement. So that is F was here, H complement is here, and their intersection is those who satisfy both female and not having health insurance. So as a result, only this type satisfies these two conditions, and the answer is A, 13.8%. Right? So as I said, this example, 2x2 example, is the simplest possible case. When you have a more complicated structure, you can make it even like much more complicated, like a intersection, union, complement, and then like do it again and again. But the principle is simple, just to see where the outcomes are. Okay. And another theorem that we can extract from that observation is the relationship between the probability of the union and the other probabilities. So think about the probability of union, F or H. So remember, union is or. What is the probability that F or H happens? And then it is like, if you want to express this using the original probabilities, we obtain some of the, we can write down the probability for the union equals sum of the original probabilities minus something. This is new. So you include both F and H, but its probability is not just their sum. You need to subtract something because there is an overlap when you add two probabilities. So there are someone who is included in F and H at the same time. Then when you add these probabilities, you are counting them twice. So you have to subtract them, and those are the intersection. So if someone is like, there is a type who are counted like twice in F and H, so you have to subtract them. This is the general addition rule. We call this addition rule. It's pretty simple, straightforward to see from the 2x2 table. And then if you open a textbook, often the addition rule refers to this equation, but I don't like this theorem. So this is just a special case. So the previous one, I'm going to call this general addition rule. It is general. It holds all the time. It is always true without any condition. But for this to be true, you have to have the intersection having probability 0, right? So there should be no overlap. Then you can express the probability of union as the sum of two single probabilities. So this is a very special case, and this is when female and H do not happen at the same time. So there is no double count. And in this case, this is a special case. In this special case, the special addition rule, simple rule holds, and we call this mutually exclusive. If this is true, we say that F and H are mutually exclusive. And then we can express the probability of union, their union, as the sum. So it's a very special case, very restrictive case. And in our example, female and H are not mutually exclusive. They are not mutually exclusive. They can happen at the same time. So some people are female and have health insurance at the same time. So they are not mutually exclusive. Example of mutually exclusive events are like female and male. So if you are female, then you cannot be male. So these two events cannot happen at the same time. Then they are mutually exclusive. Okay, this is it for this video. And in the next video, I will bring up another related topic. Thank you for watching. See you later.